Hi, I am Siddharth from CSIT branch. Today, I am here to tell about reflective sensor. First of all, we want to know the definition of reflective sensor. The definition is the emitter and receiver are installed in the same housing, and a light from the emitter is normally reflected back to the receiver by the reflector installed on the opposite side. When the sensing objects interrupts the light, it reduces the amount of light received. It is this reduction in light intensity is used to detect the body. Here we can see the diagram. Next, we can see the features. Sensing distance ranges from several centimeters to several meters. Simple wiring and optical axis adjustment, which is known as labor saving. Operation not greatly affected by the color or angle of sensing objects. Light passes through sensing object twice, making these sensors suitable for sensing transparent objects. Sensing objects with mirrored finish may not be detected because the amount of light reflected back to the receiver from such shiny surfaces makes it appear as though no sensing object is present. This problem can be overcome using the MSR function. The retroreflective sensor has a dead zone at close distances. Reflective sensor is a type of photoelectric sensor. What is photoelectric sensor? Here we know about the photoelectric sensor. Photoelectric sensor detects the photo-optical workpieces. OMRON provides many varieties of sensor, including diffuse, reflective, through beam, retroreflective, and distance settable sensors, as well as sensors with able built-in separate amplifiers and fiber units. Here we can see the diagram of reflective photoelectrical sensor. Here we can see the parts: emitting element, emitting light, and the receiving element. Next, here's the retro reflective optical sensor without a target and with a target. Without a target, it receives back from the reflector. Without a target, it is the light is blocked to the target. Here's the three types. First one is through beam sensor, and second one is retro reflective sensor, and third one is diffuse reflective sensor. Here we can see the diagrams of the respective one. Here we can know what is photoelectric sensor. Photoelectric sensor detect objects changes in surface conditions and other items through a variety of optical properties. A photoelectric sensor consists primarily of an emitter for emitting light, a receiver for receiving light. When emitter light is interrupted or reflected by the sensing object, it changes the amount of light that receives at the receiver. The receiver detects this change and converts it to an electrical output. The light source for the majority of photoelectric sensors is infrared or visible light, which is generally LED, red or green or blue for identifier colors. Photoelectric sensors are classified in as shown in the figure below. Above. Features of photoelectric sensor. The first features of photoelectric sensor are long sensors, long sensing distance. A through beam sensor, for example, can detect objects more than 10 meters away. This is impossible with magnetic, ultratone, ultrasonic, or other sensing methods. And the second one is virtually no sensing object restrictions. These sensors operate on the principle that the objects interrupts or reflects light. So they are not limited like proximity sensors to detecting metal objects. This means they can be used to detect virtually an object. including glass, plastic, wood, and liquid. Here's the third one, fast response time. The response time is extremely fast because light travels at high speed and the sensor performs no mechanical operations. Because all circuits are comprised of electronic components. The fourth one is high resolution. The incredibly high resolution achieved with these sensors derives from advanced design technology that yielded a very small spot beam and a unique optical system for receiving light. These developments enable detecting very small objects as as well as precise position detection. And the fifth one is non-contact sensing. There's little chance of damaging sensors, sensing objects or sensor because objects can be detected without physical contact. This ensures years of sensor service. Color identification. The rate of which an object reflects or absorbs the light depends upon the both the variable of the emitted light and the color of the object. This property can be used to detect colors. And the seventh one is easy adjustment. Positioning the beam on the object is simple with the models that emit visible light because the beam is visible. Here now we can see the operating properties. The first one, properties of light, rectilinear propagation. When the light travels through the air or water, it always travels in a straight line. The slit on the outside of through beam sensor that is used to detect small objects is an example of how this principle is applied to the practical use. Refraction. Refraction is a phenomena of light being deflected as it passes obliquely through the boundary between two media with two different media respective indices. Here we can see the air and glass are different media which have different refractive index as 1 and 1.5. Reflection. Angular Angular reflection, retroreflection, diffuse reflection. A flat surface such as glass or a mirror reflects light at an angle equal to incidence angle of the light. This kind of reflection is called regular reflection. A corner cube takes advantage of this principle by arranging three flat surfaces perpendicular to each other. The light emitted toward a corner cube repeatedly propagates regular reflections and the reflected light ultimately moves straight backward towards the emitted light. This is referred to as retroreflection. The most retroreflectors are comprised of corner cubes that measure several square millimeters and are arranged in a precise configuration. The meta surfaces such as white paper reflection light in all directions. This scattering of light is called diffuse reflection. This principle is the sensing method used by diffuse reflective sensor. Here we can see the three types of reflection: regular reflection diagram, which is mirror, and the retro reflection diagram, which is corner cube, and the diffuse reflection, which is a paper. Here you can see the different types of reflections. Next, polarization of light. Light can be represented as the wave that oscillates horizontally and vertically. Photoelectric sensor almost always used LEDs as the light source. The light emitted from the LEDs oscillates in the vertical and the horizontal directions and is referred to as unpolarized light. There are optical filters that constrain the oscillations of unpolarized light to just one direction. These are known as polarizing filters. Light from the LED that passes through a polarizing filter oscillates in only one direction and is referred to as polarized light. The polarized light oscillating in one direction, say the vertical direction, cannot pass through the polarizing filter. that constrains oscillations to a particular direction. That means horizontal direction. Here we can see the diagram. Here, how unpolarized light, which goes through the polarizing filter. The second one is light sources, light generation, pulse modulated light. The majority of the photoelectric sensor use pulse modulated light that basically emits light repeatedly at fixed intervals. They can sense objects located some distance away because the effects of external light interference are easily removed with the system. In modules equipped with mutual interference protection, the emission cycle is varied within a specified range to handle coherent light and external light interference. Here we can see the diagram of light source, color, and which type. Here we can see the blue LED, green LED, red light, infrared light. Here, uh, here we can see the ultraviolet light range, visible light range, and infrared light range. Next, third one is triangulation. The distance settable sensor generally operate on the principle of triangulation. This principle is illustrated in the following diagram. Light from the emitter strikes the sensing objects and reflects diffused light. The sensor lens concentrates the reflected light on the position detector. That means a semiconductor that outputs a signal according to the where the light strikes it. When the sensing object is located at a near the optical system, then the light is concentrated at a point on a position detector. When the sensing object is located at B, away from the optical system, then the light is concentrated at point B on the position detector. Here we can see the diagram. The retroreflective sensor functional principle 2. Simple installation, only one sensor head, application of reference reflector, that means mission or conveyor built background. Emitter and a receiver are integrated in one housing. Reliable detection of problematic targets, that means sound absorbing angled surfaces. Here we can see the advantages. Reliable, the main advantages are reliable, consistent object detection with no incorrect switching regardless of the shape, surface or position of the objects. The sensor do not need to relignin if the object shape or position changes. Replaces complicated, cost-intensive installations using several sensors in the series. Apart from apart from lower prices, the benefits compared to light grids include the reflection principle. While the retroreflective area sensor operates with the simple reflector, light grids consisting of a transmitter and receives and receiver must always be wired at two ends. The retroreflective area sensors are easier to install. By this, I conclude the topic retroreflective sensor. Thank you.